And in this forest monitoring, first we'll be learning about concept of forest monitoring. And talking about forest concept of forest monitoring, we can say that it can be defined as identification in the differences in the patterns of forest at two time period. It can also be said as forest change detection analysis. So that means that we have got forest or green cover data for two time period, and we are trying to find that what is the difference. Is there any difference between green cover? For example, if I have got data green covered data for 1991 and 2001, so what I'll do, I'll try to find the change which has taken place over period of time. So if that kind of detection I'm doing, that means I'm going for forest monitoring. So in India, forest cover mapping is done by Forest Survey of India, and in Indian and we can say that forest cover can be classified into four classes on the basis of canopy. First is very dense forest, where we have got 70% and more canopy. Then moderate dense, where 40 to 70% canopy. Then open forest, that is 10 to 40% canopy, and scrub, that is less than 10 to 10 percent canopy. Sorry, here percentage is missing here. So we can say that in forest monitoring, geoinformatics plays an important role. And now question arises that what is geoinformatics? So we can say for general understanding, we can say that geoinformatics is use of both remote sensing and GIS technology. We can, I mean, even GPS is also will also come under this domain. For forest monitoring, we have seen that we largely depend upon satellite imagery, and the benefit associated with satellite imagery is that uh, it is a satellite imagery is kind of a permanent record which we have at particular time and space. Then it is repetitive in coverage, because satellite passes through one particular area for cover one region, maybe in 5 days or 10 days. So we get of any space, we get repetitive coverage. And once the satellite is launched and then everything is done, so it becomes very cost effective. So we can say that, for example, Landsat series, if we see, so we have got freely available data from Landsat series, and we can make many analysis out of that. So we can say that with forest change detection analysis, for we can have four components. One, we can find detection, that what is the we can discover the changes which has taken place over a period of time. Then what kind of changes has taken place, that changes can be recognized. Then third is identification, that means we can label them. For example, we have earlier slide we have seen that we have got dense forest, then dense forest, then we have got open forest, then scrub. So like, is there any change in the category? So that kind of labeling we can do. We can identify and then label them. Then we can also quantify them by measuring area of that region. If like if I've got satellite imagery, then and if I see that there are patches of green cover, so I can draw a polygon over that green patches, and then I can find out area of that. So that exercise we can do. Next, we need to learn about methodology which we need to adopt in order to go for forest monitoring. And for that, first thing which we need is to have satellite imagery, which we can easily obtain from Landsat series or IRS series. So that is from Bhuvan. We can obtain those imageries. Then we can have, then after on those imageries we need to go do radiometric corrections and geometric corrections. Radiometric corrections are the corrections which leads to see whether there is a pixel dropout or there is a line dropout. So all those kind of corrections we all need to do in that imagery. Then we have next is image enhancement. So there are various techniques of image enhancement which you all have already learned in last semester. Then we need to create FCCC, that is false color composite. And purpose is that why do we need to create false color composite? Because usually human eyes are not capable enough to see various grades of if there is a black and white image, so we cannot see discriminate between various variations in those patterns. So we go for FCC so that we can have maximum range of color combination. And for us, it or like for human beings, those changes, identifying those changes becomes very easy. Then next step is of image classification. So image classification, we have there are various techniques of image classification. First is supervised classification, second is unsupervised, then third is hybrid, and then uh, object based classification. So talking about image supervised classification. Supervised classification is, as the name suggests, that it is supervised. That means one is supervising that. So like on the basis of our image, uh, user, what they do, they set the training sites, and then they classify image, then they allot uh, labels for those training sites. For example, in my imagery, in my false color composite, if I see something in red patch, so I can allot that red patch as a vegetation. So here I'm supervising the software, so that way is I can select various training sites and then I can allot names to them. So the entire exercise will become in supervised classification. Next is unsupervised, where it is entirely software based exercise, where we don't have the prior knowledge of the area. So what do? We go for pixel based, uh, on the basis of DN values. Um, the software will on its own make the categories or um, it will label. So we just one thing we need to decide that how many categories we want. So if I say, for example, if I want 10 categories or 20 categories, so on that basis software itself will divide the entire image into different categories. And from there we need to go for ground truthing, or else we can, after ground truthing, then we can go for supervised classification. uh, and So the main difference between supervised and unsupervised, in supervised classification, we are basically allotting land categories, while in unsupervised software itself is doing. And then there is a third category which is of hybrid classification, where we use both techniques and where we take both techniques into consideration. And next is object based classification, which is possible only in the if we have got very high resolution data. So, and is mostly visual interpretations, and that resolution so high that visual interpretation is very much possible in that. And while we are doing visual interpretation, so again all those techniques of visual interpretation, that means texture, tone, shadow, association, all those factors again we take into consideration. Then next step is of accuracy assessment, and then last step which is of change detection map. So in this, what do? We have got two two um 2 year map. One is, for example, if I've got map satellite imagery of 2001 and then 2011. So what I'll do, on 2011, I'll draw wherever I'll see green areas or the green cover, there I'll draw polygon, and then I'll overlay that polygon to the on the map of 2001, where again there is a polygon. So we'll see that is there any change in those polygons, or if there is no change, no, we don't need to make any effort. If there is a change, then the next step is to go for area calculation. Um, so that way we can go for uh, forest monitoring. So here we have got this Chhattisgarh map, and this map I have taken from Forest Survey of India 2019, and here you can see all this green cover, green cover, and for forest monitoring, what do? We can, and these green covers are basically, it shows very dense forest or moderate dense forest. Actually, these categories are not very much visible in this map, but I'll be circulating this map to all of you, and there you can see in that PDF that it is very much visible. So we'll be working on Chhattisgarh map, uh, and we all know that it is also known as herbal state. And after MP and Arunachal Pradesh, Chhattisgarh holds third position in terms of forest cover as per Forest Survey Report 2019. So students, now what? Now we will be learning about how to do forest green cover mapping. Here, we're not exactly doing forest monitoring, rather we'll be mapping areas or the districts under green dense forest, or moderate dense forest, or open forest. So that's what that is our objective. Reason being, because we don't have for monitoring, we need to set two timeline series data, which we are not using here. Uh, so this is my uh, forest forest area raster image, which I have which I georeferred, and then accordingly will be uh, will be marking all the layers. So first, for this exercise, what we need is that first we need to learn table join, and then we need to make choropleth map. This exercise already we have learned previously also, because two videos I have made. One is of table join and second is of choropleth map. So those two videos are in break. I mean, table join and then choropleth map. So here I'll be telling you once again, so that is a kind of revision for you all. So first I'll go to layer, and one thing you all need to know that whatever is your ID in your attribute table, same ID should be there for Buster and Bilaspur. So same ID should be must be there in your Excel sheet. So I have already done that part. So here my main purpose is to join table. So I'll go to layer, I'll go to add layer, then we'll go to add delimited text layer, then file name. This is new CSV file, and geometry definition. There is no geometry, as in like we are not adding any large long information here. So let's keep it like that. Then add and close. So my layer is now in my layer panel. So now next step is to join new CSV file to Chhattisgarh map. So what I'll do, I'll go to properties. Then I'll go to join, and in join you'll find this plus sign. So click on this plus sign, and it is asking for join layer. So I want to join new CSV layer to join field. So serial number and target field, I'll keep it as field ID. And what all attributes I want to join. So those attributes I need to check in here. Very dense forest, moderately dense forest, open forest, total percentage of green area. So let's keep it like that. Okay. Apply. Okay. So if I go to attribute table, you can see that my table join exercise is successful. All the tables are joined. So this you need to do it very mindfully, because if field IDs and your ID and its corresponding name is not matching in your Excel sheet, then it will not join. So that you all need to do it carefully. Now my next objective is to draw choropleth map. So what I'll do, I'll go to properties, then I'll go to symbology. Here, instead of solid, I'll apply. Okay, so now in some, I'll go to graduated. Then for which column I want to do this thing, so I'll go to percentage of green area. Okay, fine. And then precision. Precision basically tells you about after decimal what all unit you want to take. So precision 4 means after decimal 4-digit will appear. So I don't want that precision. So let's make it 0. Then color ramp, since I'm going for green. So what I'll do, I'll choose green. Then it is saying equal interval and classes. So let's keep it 5 as default. I'll make it 5, and then I'll click on classify. So now you all can see that since precision is 0, so you all can see in legend, this is the categories which has appeared. You can make it like this also. So 4.0, earlier it was now like, so let's keep it 0 only. Now I'll make it apply and okay. So now this is my map which has appeared, and if you see, if I check in this map, so it will correspond with green areas of the my forest cover raster image. So see, this is matching, right? Now my next task is to make a pie diagram. So what I'll do, again I'll go to properties, then I'll go to diagrams. Here you all have got this option of me going for histogram, text diagram, pie chart. So I'll be choosing pie chart because I want to show open area and open forest, dense forest, and moderately dense forest. So I'll go for pie chart, and then in attributes, I'll go to attributes and then I'll select what all attributes I want to show. So very dense forest, moderately dense forest, open forest, and I'll not press plus sign. And then here you can make changes. I mean, you have to write name the way you want them to appear in the legend. So very dense forest, fine. Then I'll just remove new CSV. Mm, Open forest. So these are the names. I can make changes in color also, color option also. Okay, let's make it something else. Here I'll make change and maybe I'll okay, apply, apply. Okay, wait. So now what I'll do? Apply. Placement size. Text size. Let's keep it 8. Apply and okay. So this is my map which has appeared. Okay. So you can see that these two, there is no map has appeared. I know there is a slight problem. There was a slight problem with data, so which I have not corrected. So just because this is for practice purpose only, so I'll be giving you all right data. So here, this pie diagram has appeared. So this is the we have got this magenta color showing very dense forest. then yellow color showing moderately dense forest, and then this is the dark blue which shows open forest. So here we can see that we have got two categories, that is very dense forest and then open forest, these two. So likewise you can make this choropleth map and then bar then pie diagram. Thank you students.